My name is Russell Foster. I'm Professor of Circadian Neuroscience at the University of Oxford. I also chair the Public Engagement Committee here at the Royal Society. The Royal Society is our National Academy of Science, and our mission is to promote science and engineering at every level, and also the understanding of science and engineering. And that's part of what the Summer Science Exhibition is all about. What you've got is this fantastic opportunity for scientists and engineers to meet directly the individuals who pay our wages. And there are so few opportunities whereby we can engage directly. There's usually a veil of the newspapers or the media in between. And the opportunity of understanding the interests, the fears, the concerns of the non-specialist about our science, I think is absolutely superb. The exhibition this year is as diverse as ever. We've got everything from the origins of the universe to a school project about the fascinating biology of birds. And they've been attracting just as much interest as satellites and comets and biomedicine.
My name's Amanda Naylor and I'm a teacher from Maltby Academy in Rotherham, South Yorkshire. Our exhibit is called The Secret Life of Birds and it's a partnership with the University of Sheffield and it's funded by the Royal Society. The main aim of our project is to set up a field site at our school, and we have put cameras around the school site to capture bird behaviour. We've also set up with our Year 8 pupils several feeding experiments. This is to see how the feeding behaviour of birds changes throughout the seasons and also to see whether they prefer to eat from high feeders or low feeders. We've also had the researchers coming in from the University of Sheffield to teach both Year 8 and Year pupils about different aspects of the egg.
Hello, my name's Joey and we've been learning about what birds doing, like when you're not looking. We've been putting wildlife traps up to record what birds do in the spare time, like feeding, and we've noticed that the blue tits and the great tits feed really high, and like most of the other birds go on the low feeders. And we've been having quite a lot of sabotage by like squirrels and other predators eating all the seeds.
My name's Erin and we found out from the University of Sheffield that eggs have pores in them, so oxygen can go in and out and carbon dioxide can come out, and it also has a protective membrane around it to stop anything from going in that doesn't need to be in.
I'm Dr. Jason Forshaw. I'm from the Surrey Space Centre, University of Surrey, UK. And I have a stand here, and the title of the stand is Cleaning Up Space Junk. It's actually 7,000 tonnes of junk actually in space, and what we aim to do is really launch a mission next year. The mission's called Remove Debris, and the aim of this mission is actually to go up there and grab junk using a net and a harpoon and bring it back down to Earth where it will burn up. This is a topic that's been under discussion since maybe the 1960s and 1970s. However, nobody really up to this point has had funding to deal with it fully, and we believe we're going to be one of the world's first consortiums which are actually able to deal with this problem. Of course, we have funding from the EU to do this, and we're going ahead, and hopefully that will happen next year. So people always ask, why is space junk a problem? Well, the reality of it is that there's loads of operational spacecraft flying about with lots of junk in space, and the risk of collision is actually really high. In 2009, the Iridium 33 collided and produced thousands of fragments of actual debris. The International Space Station also has to regularly move out of the way of junk, which is a real collision hazard. It has to move various times a month, which just shows how real this real threat is to space.
My name's Neil Gow, and I'm a scientist who studies diseases which are caused by fungi, human diseases which are caused by fungi. And our exhibit's called Killer Fungus, and that gives you the impression that there are fungi which can kill human beings. So the total number of people who are dying is difficult to get precisely, but it's in the region of 1 to 1.5 million people a year. That's 2 or 3 times the number of people who die from breast cancer. So we're trying to educate people a bit more about the perils of some classes of fungi, and we're joined by a whole lot of young scientists who are working in this field who are trying to do something about it. What we can see here is a mannequin which shows you where fungi infect the human body. And that's a bit worrying as well, because there are some fungi which infect the brain and the brain stem. Meningitis, fungal meningitis in Africa kills about 600,000 people a year, maybe even more than that. It's not just awareness. We've got a whole series of movies by people who are actually working in this field, and they're making a difference. We're learning much more about the diseases, and by knowing about the disease, we know more about treatments. We're raising antibodies which can be used to diagnose these infections earlier. That's important because if you have a late diagnosis, you have a poor prognosis. So early diagnosis is key to successful treatment. And there are people here who are also interested in antibiotic resistance and trying to find new classes of antibiotics or making antibiotics work better in the future. We don't have as many types of antibiotics against fungi as we do against other types of bugs like bacteria. But we do have them, but it would be fair to say none of them are quite as good as something like penicillin, which tends to kill bacteria, and most of our antibiotics actually just hold them in abeyance. Some kill them, but not all, so there's a lot of work still to be done.
My name's Jenny, and I'm a second-year PhD student in the Earth Sciences Department at the University of Cambridge. Our group is looking at earthquakes and volcanoes, and in particular in Iceland. So the reason we're studying them is that earthquakes tell us about what's going on underground, where we can't obviously see, and it can tell you where molten rock is moving. So it's used in early warning system, hazard monitoring of volcanoes. So some people are calling us volcano chasers. At the time we were there putting out more instruments to detect the earthquakes and track the movement of the magma underground. And what actually happened is we predicted where it might erupt so closely that one of our seismometers we had to pull from the advancing lava before it was overflowed and lost forever. It's important to be able to track what's going on underground so that we can warn people and evacuate areas, warn aviation authorities, because of course you don't want to fly a plane through an ash cloud, it might stall the engines, and save lives.